Before engaging with this task, students need to have spent time at Junior Cycle exploring the multiplication of real numbers, with particular emphasis on the geometric view of multiplication, and to consider the scaling effect of multiplying by a real number and a rotation of 180 degrees when multiplying by a negative real number. Students should also revisit these ideas at Senior Cycle and continue the exploration to consider the effect on a real number of multiplying by I and discovering that the effect on the real number is a 90-degree rotation. Through this investigation, students can construct the imaginary axis. In this task, students will explore the effect of multiplication on these newly discovered numbers. Students will be presented with a GeoGebra file, and the teachers will use effective questioning to facilitate the key learning. When the students click on the link, the following GeoGebra file is displayed. We want the student to investigate the properties of the newly discovered numbers. When we click on the first checkbox, two numbers will display, a real number A and a complex number BI. The pink number displayed is the resulting product of multiplying BI by A. The student can use the sliders to change the values of A and B. The student should record the results and draw their own conclusions from this investigation. We want them to notice that when A is positive, the effect on our new complex number BI of multiplying by A is a scaling by a factor of A. When A is negative, we want our students to notice that there is still a scaling by a factor of A, but that there is also a rotation of 180 degrees. The teacher can use effective questioning to support the student's learning. Prompt questions, such as, "What do we already know about the multiplication of real numbers?" may be useful if students are unsure where to begin. For students who are making good progress with the investigation, the use of predictions can help extend the task. What might happen if? It is important that at the end of each investigation, students are creating a bank of information. They should have an opportunity to form conclusions in their own words. At each stage, the student can summarize the key learning once the student has reached the correct conclusion. The second investigation is to consider the effect on a real number of multiplying by our newly discovered complex numbers. Before we begin, we could ask students to make a prediction of what they think the outcome will be. Click on the second checkbox. We are now considering the effect of multiplying a real number A by a complex number BI. Students have previously investigated the effect of multiplying any real number by I. Students can revisit this prior knowledge by changing the value for B to be 1. Students can then investigate the effect of multiplying by a multiple of I. Students can then investigate the effect of multiplying by a multiple of I, for example, multiplying by 2i, 3i, etc. The key learning here is that when I multiply by a multiple of I, there is a 90-degree rotation and a scaling by a factor of B. Students should investigate, record their own results, and draw their own conclusions. It is also important that students consider the cases where A or B are negative. At each stage of the investigation, students should be asked to consider why this might be, and to justify their thinking. Our students should be able to conclude that when B is negative, there is a scaling by a factor of B and a rotation of 270 degrees. We can ask our students, why is there this rotation? Our students should know that there is a rotation of 90 degrees, which is the effect of multiplying by I, and a rotation of 180 degrees, which is the effect of multiplying by a negative real number, which combines to result in a rotation of 270 degrees. The third task is to investigate the effect of multiplying a complex number by a complex number. Click on the third checkbox. The blue number displayed is the complex number Z1 equals AI, and the pink number displayed is the result of multiplying Z1 by BI. Students should try different values for A and for B, choosing positive and negative values in order to support this investigation. Students should be able to provide a convincing argument to explain these findings. Following on from these investigations, students should be able to suggest the general rules for multiplication of complex numbers. Teachers can summarize the key learning and highlight how the newly discovered rules are consistent with the rules for multiplication of real numbers. At each stage of the investigation, teachers can use a mixture of recall, prompt, application, and extension questions to support students' learning. Questions such as, what has led you to that conclusion? Is there evidence to support that conclusion? What assumptions did you make? Can all be useful in supporting students' thinking. At the end of the investigation, it is important to summarize the key learning from the tasks for the students. Students should take a record of this summary and should also be given an opportunity to reflect on this new learning.